All right, let's talk about data. Specifically, what happens when the most important part of your data isn't the individual pieces of information, but the web of connections between them. We're going to dive into what happens when you need to go beyond standard tables and really explore those deep relationships. So let's just get right to it, especially for those of you who live and breathe SQL. You've spent years mastering relational databases. You can write complex, multi-level joins with your eyes closed. It's the foundation of modern data work. So, why on earth should you care about a completely different way of looking at things like graphs?
For decades, SQL and relational databases have been the king of the castle, right? They are incredibly powerful, they're reliable, and they are fantastic at handling structured data, whether it's customer records, financial transactions, you name it. But there are certain types of problems where this superstructured approach starts to, well, show some cracks.
And here's the interesting part. It's almost a little ironic, isn't it? A relational database that can struggle with relationships? It sounds weird, but the reason is that these systems are built to store the things, the entities, and the connections between them are only figured out at query time using joins. When your questions become less about the things and more about the path between them, things can get really complicated really fast.
This brings us to a classic textbook example that shows this limitation perfectly. It's a question that seems incredibly simple on the surface, something you do on a social network without even thinking about it, but it can bring a powerful relational database to its knees.
Okay, so picture this tiny social circle. You've got Charles, who's friends with Bill and Diane, and Bill, he's friends with Anne. Now, the question we want to ask is, who are the friends of Charles's friends? I mean, looking at it, the answer is obvious, right? It's Anne. Seems easy enough.
Well, before we can even try to answer that question with SQL, we have to solve the first problem. How do we cram this simple, intuitive network into the rigid boxes of a table-based structure? This is our first hurdle.
Typically, you'd do something like this. You'd have a users table with a unique ID for everyone, and then you'd have a friendships table, which is basically just a big list connecting one user ID to another. So, user 3, Charles, is friends with user 2, Bill. That's one row. Charles is also friends with Diane. That's another row. Every single connection gets its own line.
All right, so we've got our data modeled. Now let's try to ask our simple question. Who are the friends of Charles's friends? And this is where we start to get, well, lost in the joins.
Finding Charles's direct friends is no problem. That's a simple single join. But to find the friends of those friends, you have to do something much more complicated. You have to join the friendships table back onto itself. You're basically telling the database, okay, first find everyone connected to Charles, and then, for each of those people, find everyone they're connected to.
And this is where the problem just explodes. What if you wanted to find friends of friends of friends? Well, that's another self-join. And one more level deeper? Yep, another join. The query becomes a monster and the performance just plummets because you're forcing the database to do this massive repetitive work of rebuilding these connections from scratch with every single hop.
This quote really just hits the nail on the head. SQL is brilliant for querying data inside of tables, but it was never really designed for following a trail of connections. And that trail, that's exactly what a graph is all about.
So if tables and joins are the wrong tool for the job when we're exploring these deep, winding relationships, then we need a totally different model. We need a model where the relationships themselves are the star of the show, not just some calculation we do later.
And that brings us to a different way of looking at the world. Instead of forcing our network data into tables, let's just embrace its natural shape. It's time to start thinking in graphs.
The graph data model is actually beautifully simple. It really just comes down to two things. You have vertices, which are just the entities, the people in our example, and you have edges, which are the actual connections, the relationships between them. That's it. No tables, no foreign keys, just the dots and the lines connecting them.
So, looking at them side by side, you see the huge difference. In the relational model, connections are something the database has to figure out every single time by doing expensive joins. But in the graph model, the connections are stored directly as part of the structure. They are first-class citizens, just as important as the data points themselves.
Now, if you store the data differently, it only makes sense that you query it differently too. We can completely forget about joins. Instead, we do something that feels a lot more like how we think.
To find friends of friends in a graph, you literally just take a two-step walk. You start at the Charles node, you take one step out along his is-friends with edges, and you land on Bill and Diane. Then, from those nodes, you just take one more step out along their edges, and boom, you've arrived at Anne. It's not a complex logical puzzle for the database. It's a simple walk along a path.
So where does this new way of thinking fit into the database world you already know? Well, it helps to think of it alongside OLTP and OLAP. You know OLTP, it's for fast, everyday transactions, like updating a user's profile. And you know OLAP, that's for heavy-duty analytics, like summing up quarterly sales. Graph processing is this third distinct thing. It isn't for single updates or big summaries. It's purpose-built for relationship analytics, for hopping from node to see how things are connected.
And really, that's what it all boils down to. It's about using the right tool for the right job. Your relational database is still absolutely critical. But when the questions you're asking are all about networks, influence, and how things are connected, doesn't it make sense to use a system that speaks the language of connections?
And that's our look at the world of graph querying. Hey, if this helped you connect a few dots, we'd really appreciate it if you'd like and subscribe for more explainers just like this one. Thanks so much for joining us.